LLMs are incredibly powerful and at the same time very dumb. All the knowledge they have is baked into them. So what if we could make any tool available to them, be it through files, APIs or databases? MCP is here to solve this problem. It enables LLMs to access your calendar, create meetings or reserve a table at your favorite restaurant. In this video, I want to explain to you how that works, why we need that, and go over a very simple server that implements MCP with two tools. So let's get started. We will first go over what MCP really is and why it matters. Then we will discuss some core concepts such as the client, the server, the tools, the prompts, and everything else. We'll also go over transport systems, so we'll cover stdio and StreamableHTTP, and we'll cover some basic versioning as well as authentication basics. And then we'll build up a minimal MCP server and expose two tools. Finally, we'll learn how a UI, be it a mobile, a desktop, or a web app, can talk to the MCP server safely. So the goal is to keep it practical, give you all the tools and knowledge to either build your own MCP server or understand the fundamental concepts so you can build upon them. So let's dive right in. MCP, or the Model Context Protocol, is an open protocol that standardizes how AI apps provide context and tools to models. Messages are JSON RPC 2.0 based, and they have a negotiation step when the client connects to a server. The servers can then expose resources, which are readable context like files or rows. Prompts will also be exposed, which are just templates for interactions between the client and the server. And finally, it can expose tools, which are callable functions, which have a JSON schema as an input. And they can provide some form of output. Clients can also optionally offer sampling, so servers can request an LLM call through the client without any API keys needed on the server side. Under the hood, you will see a short initialize capabilities operate lifecycle with explicit version negotiation, which is using date-based versions like a date string. So how does the communication work then? Well, MCP defines two standard transports. First is stdio, which is used for local subprocess servers. And the second one is StreamableHTTP for network servers. When we use HTTP, there's also an OAuth 2.1 style authorization profile. With stdio, we don't need this. Credentials can come from either the environment or the local context. With these fundamental concepts now in the back of our head, we can now start building out a very tiny MCP tool server. We will use Node.js and TypeScript, but you can just use any other tooling system. So for example, it would also work with Python or Go. We will expose two tools. The first will be a fetch user tool, which is read-only. And then we also create a create ticket tool, which has a side effect. Each tool declares its own input schema and returns typed content. We'll use Anthropic's MCP package to build up our MCP server. First, we need to import a few types, such as the MCP server and the stdio server transport. We'll also need to use Zod for providing a schema. Then we define an MCP server, which we will give a name and a version. Then we can start with registering our first tool. We'll call it fetch user. We'll describe a bit in more detail what it does, which will be important because agents or LLMs need to decide which tool to use when, and for this a very solid description is essential. We also define the input schema using Zod, and then we define an async function which gets the input schema as its input and can then do its work. Here we just create a demo user. This is something we would replace later on with a regular database or API call. And then we return this content, we give it the type text, and we put the JSON that we received from anywhere into a string so that we can return it safely. As a second tool, we will now register the create ticket tool with a title, a description, and a slightly more complex input schema, where we can use all the types that Zod gives us. Then again, we define the function. We take the user ID, the title, and the priority in that case, and we feed this into our tool, and we pretend to now call our issue system, and we return the link to the created ticket. And finally, we return this. So we again create the content object here, and we return the type text and say that the ticket was created. Finally, we can now define the transport system we want to use. For us, this is now the stdio server transport, and then we connect the server asynchronously. The SDK now wires up JSON RPC messages and the lifecycle for us. The input schema uses Zod here, but it finally binds to any JSON schema at the protocol layer. So this is just for the convenience of our implementation. Clients can now discover tools using the tools/list command, and they can invoke them with the tools/call command, getting back typed results. Now, in case we want to change this to the StreamableHTTP variant, this is quite easy. We can simply import a server such as Express and also import the StreamableHTTP server transport type from the MCP package. Then we define our server, and we can wrap our server into the StreamableHTTP server transport object, just defining a path. Here it's /MCP. Then again, we connect the server and we listen on port 3000. So this is the Express app just being initialized. The cool thing is that StreamableHTTP now allows us to do streaming and server client notifications through one endpoint with resumability and sessions. So this is all that we need to do to implement an MCP server, which is not a lot of code. Granted, we just used demo API calls now, but I think the principle is clear. And now we can think about how we can actually integrate this into our UIs. Again, I'll use TypeScript code, but the concept applies to any other platform. So let's take a look at how we would do this. First, we would call the MCP route, and we define the protocol, so JSON RPC 2.0, and we define the initialize method, and we hand in some parameters such as a protocol version, the capabilities, and the client info. Then we can call the list endpoint to list all the available tools. And finally, we can post to the tools/call to initialize a tool, such as in our case, the create ticket tool with the required arguments. Otherwise, it would give us an error. Again, in the browser, we can go through our backend for CORS, authentication, and to keep our secrets server-side. On the desktop or the client, we can spawn the server using stdio. In the initialization step, we also negotiate the version as well as the capabilities. I think it's also important to note that MCP has seen rapid adoption across all the tooling such as editors and assistants, which is probably accelerating the standardization of the ecosystem quite a bit. With this rapid adoption, it becomes more and more important to ensure that safety and trust is always given. And there are a few things to keep in mind there. First, the human in the loop concept says that clients should always require user consent before invoking tools. Listing tools should be fine. So UIs should always show what's being called with which arguments. Second, the HTTP auth mechanism should always be respected. For stdio transport, that is not necessary because this is just using local tooling. And last, the least privilege concept states that the scope of the tools should always be as narrow as possible. We should always sanitize the outputs to ensure that there's no private information being shared. And we should always lock the output of our tool calls and the MCP server for later audit. So with that, we have seen how the basic concepts of MCP works, how we can implement a server, and finally how we can call this server on our client. Again, stdio is perfect for local development with desktop extensions or CLI helpers. StreamableHTTP, on the other hand, becomes more important if we go through the web, so if you have hosted servers, or if you want to have access from mobile or web clients. I think MCP is a very fascinating concept that helps LLMs become incredibly powerful. Do you have any ideas where you want to use it? Then please share them in the comments, and while you're at it, don't forget to like this video and subscribe to the channel. If you're interested to hear more concepts or explainers about AI and the tooling behind it, please also let us know. For now, I wish you a wonderful day and see you soon. Bye bye.